Cable staplers are indeed commonly used by electricians during the rough-in phase of house wiring. They offer a more efficient and less time-consuming alternative to manually stapling wires. Several manufacturers, including Greenlee and Klein, produce a range of cable staplers designed for various applications. Let's explore some of these models and their features. Greenlee offers several cable staplers. Firstly, there's the Greenlee EC1030 cable stapler. This is a versatile stapler suitable for driving staples into Romex, UFB, BX, MC, and AC cables. Secondly, the Greenlee EC1045 cable stapler. This model is a heavy-duty stapler specifically designed for larger cables such as 14.3 and 12.2 nmb. Klein also offers cable staplers. 1. The Klein 1005 cable stapler is a lightweight and compact stapler ideal for working in tight spaces. 2. The Klein 1006 cable stapler is a more heavy-duty option capable of driving staples for Romex, UFB, and MC cables. 3. The Klein 1009 cable stapler is a premium stapler featuring a rotating head for easier access in hard-to-reach areas. There are several benefits to using a cable stapler. One such benefit is faster stapling. Cable staplers can drive staples at a much faster rate compared to manual staplers. Another benefit is reduced fatigue. The ergonomic design of cable staplers helps to reduce hand fatigue, especially during long wiring jobs. A third benefit is consistent stapling. Cable staplers ensure consistent staple placement and penetration, resulting in a more secure and professional installation. Finally, a significant benefit is improved safety. Using a cable stapler minimizes the risk of accidental punctures or cuts that can occur during manual stapling. When using a cable stapler, keep these tips in mind. 1. Choose the correct staple size for the cable you are working with. 2. Always use staples that are specifically approved for the type of cable you are installing. 3. Hold the stapler firmly and apply even pressure to ensure optimal staple penetration. 4. Inspect the staples regularly and replace them as needed to maintain proper functionality. Now let's delve into more detail about the types of cables mentioned and their typical uses. Romex or NMB cable is a common type of non-metallic sheathed cable used for interior wiring in residential buildings. It typically contains 2 or 3 conductors plus a ground wire and is suitable for dry locations. UFB cable or underground feeder cable is designed for direct burial in the ground. It's often used for supplying power to detached garages, sheds, or other outdoor structures. The X cable, also known as armored cable or AC cable, consists of conductors wrapped in a flexible metal sheath. It's often used in commercial and industrial applications where greater protection against physical damage is required. MC cable or metal-clad cable is similar to BX cable but offers even greater protection. It's often used in high-traffic areas or where there's a risk of exposure to oil, chemicals, or moisture. When selecting a cable stapler, consider the types of cables you'll be working with most frequently. If you primarily work with Romex and other non-metallic cables, a lighter-duty stapler like the Greenlee EC1030 or Klein 1005 may be sufficient. However, if you frequently work with larger cables or armored cables, a heavier-duty stapler like the Greenlee EC1045 or Klein 1006 would be a better choice. The Klein 1009, with its rotating head, can be particularly useful for working in tight or awkward spaces where a standard stapler might be difficult to maneuver. Proper staple selection is crucial for a secure and safe installation. The staple should be long enough to penetrate the wood framing adequately but not so long that it could damage the cable insulation. Most cable staplers are designed to accept a range of staple sizes, so be sure to check the manufacturer's specifications to ensure you are using the correct staples for your stapler and cable type. Always use staples that are listed or labeled for use with the specific type of cable you're installing. This information is usually printed on the staple packaging. Using the wrong type of staple can damage the cable or create a fire hazard. When stapling cables, it's important to follow the National Electrical Code, or NEC, guidelines for spacing and support. The NEC specifies the maximum distances between cable supports and the minimum distance from boxes and other enclosures. For example, NEC Section 334.30 covers the support requirements for NM cable. It generally requires that NM cable be supported every 4.5 feet and within 12 inches of every box or fitting. Similar rules apply to other types of cables, so it's essential to consult the NEC for the specific requirements for the cable you're installing. When using a cable stapler, hold it firmly and apply even pressure to ensure the staple is driven straight and flush with the wood surface. Avoid angling the stapler, as this can cause the staple to bend or break. If the staple doesn't penetrate fully, don't try to force it. Instead, remove the staple and try again with a new staple. Regularly inspect the staples in your stapler to ensure they are not bent, damaged, or corroded. Replace any damaged staples, as they can jam the stapler or cause misfires. Also, periodically clean and lubricate your cable stapler to keep it in good working order. Follow the manufacturer's instructions for cleaning and lubrication. In addition to cable staplers, there are other tools and techniques that can help speed up the wiring process and improve the quality of your work. Wire strippers are essential for removing insulation from wires without damaging the conductors. A good set of wire strippers should have multiple stripping holes for different wire gauges and should be comfortable to use. Wire connectors, such as wire nuts or push-in connectors, are used to join two or more wires together. Choose connectors that are appropriate for the wire gauge and the number of wires you're joining. Labeling wires can save time and reduce confusion later on. Use a wire marker or label maker to identify each wire with its circuit number or function. When pulling wires through walls or ceilings, use a fish tape or wire snake to guide the wires through the concealed spaces. A fish tape can also help you locate existing wires or obstructions. Proper lighting is essential for safe and efficient wiring work. Use a portable work light to illuminate the area you're working in. Always wear appropriate personal protective equipment, or PPE, when working with electricity. This includes safety glasses, gloves, and insulated tools. Before starting any electrical work, always turn off the power to the circuit you'll be working on at the circuit breaker panel. Use a voltage tester to verify that the circuit is energized before touching any wires. If you're not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity can be dangerous, and it's always better to be safe than sorry. Keep in mind that electrical codes and regulations vary from location to location, so it's essential to familiarize yourself with the codes in your area. Your local building department can provide you with information on the applicable codes. Staying up to date on the latest electrical technologies and techniques can help you improve your skills and efficiency. Attend training courses, read industry publications, and network with other electricians to stay informed. Wiring a house can be a challenging but rewarding task. By using the right tools and techniques, and by following the applicable codes and regulations, you can ensure a safe and reliable electrical system. The use of cable staplers is a crucial element to reduce install times. By carefully considering the types of cables, selecting the correct staple size, and following the NEC guidelines, you can achieve professional results while prioritizing safety. Now let's explore some additional considerations when using cable staplers. One important aspect is the material of the framing. While wood is the most common material, you might encounter metal studs or concrete walls, especially in commercial or industrial buildings. When working with metal studs, you'll need to use cable staples specifically designed for metal framing. These staples typically have a hardened steel point that can penetrate the metal without bending or breaking. When working with concrete walls, you'll need to use concrete anchors or adhesive cable clips to secure the cables. Cable staplers are generally not suitable for use on concrete surfaces. Another consideration is the presence of insulation. If you're stapling cables to insulated walls or ceilings, be careful not to compress the insulation too much. Compressing the insulation can reduce its effectiveness and create a fire hazard. Use staples that are long enough to secure the cable without compressing the insulation. When stapling cables near corners or edges, be sure to leave enough space to prevent the cable from being damaged. The NEC typically requires a minimum distance of 1.25 inches from the edge of a framing member to the nearest cable. Avoid stapling cables to pipes, ducts, or other mechanical systems. This can damage the cable or the mechanical system. Also, avoid stapling cables to surfaces that are subject to vibration, such as machinery or equipment. Vibration can cause the staples to loosen or break. When running cables through bored holes in studs or joists, be sure to protect the cables from abrasion. Use cable bushings or grommets to line the holes and prevent the cables from rubbing against the sharp edges of the wood. When splicing wires, always use approved wire connectors and ensure that the connections are tight and secure. Loose connections can cause overheating and create a fire hazard. After completing the wiring, carefully inspect all of your work to ensure that it meets the applicable codes and regulations. Pay particular attention to the stapling, cable routing, and wire connections. Before energizing the circuit, use a multimeter to test for shorts and ground faults. This can help prevent damage to the electrical system and ensure the safety of the occupants. When troubleshooting electrical problems, always disconnect the power to the circuit before touching any wires. Use a voltage tester to verify that the circuit is de-energized. Be careful when working around live electrical equipment. Wear appropriate PPE and use insulated tools. If you're not sure how to troubleshoot an electrical problem, hire a qualified electrician to do the work for you. Regular maintenance can help prevent electrical problems and extend the life of your electrical system. Inspect the wiring, outlets, and switches periodically, and repair any damage or defects. Keep the electrical panel clean and free of obstructions. Test the ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs, regularly to ensure that they are working properly. Replace any worn or damaged electrical components, such as outlets, switches, or light fixtures. By following these guidelines, you can ensure a safe and reliable electrical system for your home or business. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always take precautions and follow the applicable codes and regulations to protect yourself and others from electrical hazards. Now let's consider some more advanced applications of cable staplers. In commercial and industrial settings, cable staplers are often used to install large quantities of cable in a short amount of time. For example, in a new office building, hundreds or even thousands of feet of cable may need to be installed for lighting, power, and data communications. In these situations, the speed and efficiency of a cable stapler can be a significant advantage. When working on large projects, it's important to plan the cable routing carefully to minimize waste and ensure that the cables are properly supported. Use cable trays, ladder racks, or other support systems to keep the cables organized and prevent them from sagging or tangling. When installing cables in plenum spaces, which are spaces used for air circulation, be sure to use plenum-rated cables that are designed to resist the spread of fire and smoke. Plenum-rated cables are typically more expensive than standard cables, but they're required by code in many jurisdictions. When installing cables in hazardous locations, such as areas where flammable gases or vapors may be present, be sure to use explosion-proof cable fittings and enclosures. Explosion-proof equipment is designed to contain any internal explosions and prevent them from igniting the surrounding atmosphere. When working with low-voltage cables such as telephone, data, or security cables, be careful not to damage the insulation. Low-voltage cables are more sensitive to damage than power cables, and even a small nick or cut in the insulation can cause signal degradation or interference. Use cable ties or Velcro straps to bundle and support low-voltage cables. Avoid using metal staples or clamps, as these can damage the cables. When installing cables in underground conduits, use a cable lubricant to reduce friction and make it easier to pull the cables through the conduit. Cable lubricant is typically a water-based or silicone-based compound. It is applied to the cables before they are pulled into the conduit. When installing cables in wet locations, such as bathrooms or kitchens, be sure to use waterproof cable connectors and enclosures. Waterproof equipment is designed to prevent moisture from entering the electrical system and causing corrosion or electrical shorts. When working with fiber optic cables, be extremely careful not to bend or kink the cables. Fiber optic cables are very fragile and can be easily damaged if they are bent too sharply. Use cable trays or conduits with a minimum bend radius of 10 times the cable diameter. When splicing fiber optic cables, use a fusion splicer to create a permanent and low-loss connection. Fusion splicing involves melting the ends of the fibers together to create a seamless joint. When testing fiber optic cables, use an optical time domain reflectometer or OTDR to measure the length, attenuation, and reflections of the cables. An OTDR can help you identify any faults or problems in the fiber optic system. By following these guidelines, you can ensure a safe and reliable electrical system for any type of building or application. Remember that electrical work can be complex and challenging, so it's important to have the necessary skills and knowledge before attempting any electrical installation or repair. If you're not sure how to do something, hire a qualified electrician to do the work for you.